Hello friends, welcome to Joy of Life. So today we are having the fifth episode of System Design Fundamentals, and before I begin I wanted to thank you all and wish you a very happy 2022. It's been an extraordinary year for the channel. So I have started the channel last year sometime around this time, and within a year the kind of support and love that I have got from you guys was tremendous. So thank you for the same. The channel has 1577 subscribers till date and lot of contents, and it was well received by all of you. So thank you. Keep supporting the channel and I will try to meet the expectation that you guys have. So looking at some of the comment that we have got. So first from Nishant Thakur, thanks Joy for sharing this. Looking forward to the entire series. Definitely Nishant, we are going to carry on with the series. Mahendra says very well explained with example. Going forward, please do implementation wherever is suitable so that we can get crystal clear idea. So I did that. This was for episode 1. We did that for episode 2, 3 and 4. Aditi says very clear explanation, eagerly waiting for the next video in the series. So Aditi, we are already at 4 episodes and today we are having the 5th one. So do let me know if you have any questions, doubts in the comment section. John Week says very well explained. Please don't stop the series. Definitely, John, I am also looking forward to it. Do let me know all your doubts. You have been the one who's most active on the series and it was good to hear from you. Do let me know your doubts and I'll try to meet them. Ramakrishna Kilana says excellent Joy. Really like all your videos, especially the tech stack. Looking for more videos. So thanks Ramakrishna. Most of them are on the tech stack only. So do let me know if you have any doubt, comment, or if you want me to create any particular video on any particular topic, do reach out to me on the same. Hack with Harsha says thank you for bringing the series. So thanks Harsha for your comment and definitely we'll keep this going. Shivam says suggestion make video on Reddit. So yeah, we are definitely going to do that. Shiva Prasad Reddy says please add more explanation of why and what is required. Definitely Shiva, keep watching the series and I'll cover everything in details as much as possible. Andres says thank you very much. Thanks Andres. I'm glad that you have liked it. So once again, thanks all of you for the comments and liking the series. It received a lot of love. Thanks to all of you. So in the last episode, we have got a couple of comments. Thanks for answering the question. Explanation by demoing in AWS really helped. Just a small question. I didn't find an option in AWS load balancer to distribute the traffic. So John, take advantage of the integration that we have. I've shared the link with you over here. So here you can easily do the integrations. If you remember, we had an integration option. You can choose that to get this done. Krishna says, awesome work. Thanks, Krishna, for your comment. I will try to live up to your expectation down the line. So with that, we'll begin today's episode. And today we are going to talk about something different. So in the last episode, we have talked about the load balancer, the API gateway. We had multiple load balancer and multiple API gateway. We always talked about it that we are not going to have a single point of failure. Right, so we talked in terms of both these guys over here, but we haven't talked about the DB or the storage, right? So we have storage in many of the places like here, right? So we are going to start with the database part. So we are going to look at the storage over here. So we are going to see how we are going to keep the storage in a way that we don't have a single point of failure. So when it comes to storing data in a database, we have two choices. One is a SQL, the other is a NoSQL. SQL databases are primarily meant for your relational data. Here what we can have is we can have data stored in tables, multiple tables rather, and we can link those tables. So let's say I have a table over here and I have another table over here. So let's say this is my user table and this is my order table. The user will have something called a ID. Let's say the first field is ID, and then order will have something called a order ID, and we'll also have something called a user ID. This user ID is nothing but this ID over here. So we can make use of this IDs to join the tables and to retrieve the data for a particular user. I can go ahead and fetch all the orders that is there in this table, right? So this kind of queries are made using something called a SQL or a structured query language. Point to keep in mind over here is that a SQL and a NoSQL is completely different thing. It's not a competitor of each other. SQL has some use cases and NoSQL has some other use cases. It's not that NoSQL is a replacement for a SQL. So NoSQL data are mostly, we keep it in a non-relational way. That means we don't join tables in order to get the data. So this is kept in various format, but this data, the nature of this data is distributed so that we can have the data in multiple places. But in SQL databases, you will see mostly the data is stored in a single machine. So let us move to the sheet over here. The first point is we have the relational and non-relational data. So for storage, I would say that this one mostly works on your table kind of storage. When I say that it has a table, that means it has a schema. So you have to define earlier that what is the structure of your data. So if you are creating a table like user, then you need to define that user will have an ID, he will have a name, he will have an address, he will have a phone, let's say. Right? So tomorrow if I need to add something new over here, I need to come and change the schema in order to do so. But the NoSQL database is schemaless and it can store data in several ways. So what could be the storage type of this? It can be a key value, it can be a document. We are going to see in a lot more details. It can be a graph, or it can be a wide column store as well. Now coming to querying, so if you want to query the data, you can use a SQL query in this case. But here we don't have anything fixed, nothing is fixed. So no standard has been defined for querying, because you can understand that data can be of various type. It can be key value, document, graph, wide column. So there is no single standard to query the data from the database. Coming to another important part over here, the scaling part. So mostly the SQL database is scaled vertically. That means I will improve my RAM, improve my SSD or the processor. I can improve all of them. But over here, the scaling is done mostly horizontally. That means I'll add more machines. So it's like a building. You can consider over here that I have a building over here with just one floor. This is my balcony. I'm very bad at drawing. So if you want to scale, if you want to store more people, you will add more floors to it, right? As you need, you're going to add more floors. So this becomes your bottleneck over here. But here I have a single house, and if I need to fit in more people, I will go for another house. So this is more of a flat concept, and this is a villa concept, you can say. So we have already talked about the horizontal and vertical scaling. So do check out that video. So that is going to come handy for understanding this. Another important property that we have for the SQL database is something called the ACID property. There is no ACID in NoSQL databases. So ACID stands for, A stands for atomicity, C stands for consistency, I for isolation, and D for durability. So in a single sense, I can say that if I have to execute 10 queries, I can say that execute all or nothing. So all of the query, all of these 10 queries should get executed, or nothing should get executed. If I have say 10 query, I have Q1, Q2, Q3, and Q9 and Q10. Let's say this query has failed, so it is going to roll back whatever it did. It will only succeed when all of them succeeds. Otherwise, it's not going to consider it. So it's a very, very important property for banking system and many system, as a matter of fact. What are the other benefit of having a SQL? So SQL, we can have other benefit is writing complex queries is a very big benefit, but we cannot write complex queries over here. We have to query at table, or you can call it collection, or whatever it is, at collection level. You cannot have a complex query wherein you are joining multiple tables in order to get the data out of the system. And now to give you some examples of both SQL and NoSQL database. So we have the popular MySQL over here. We have the Postgres. We have Oracle, and we have Microsoft SQL as well. And coming to the NoSQL part over here, you have a lot of choices over here. You have Cassandra, you have Mongo, even you can consider Redis. This is also a NoSQL database, mostly a key value store, but persistence is not there, but you can still use it for caching and other solutions like that. Apart from that, you have Neo4j for graph, you have CouchDB, and many others. So here are the difference at a very high level. And once again, to mention that SQL and NoSQL, neither they are substitute of each other. They have their own different purposes, right? It's more like an axe and a hammer. You can say that it's has two completely different purposes, right? So for putting a nail, you are not going to use a axe, right? Or to chop a tree, you are not going to use a hammer. So it's completely different. So do not think that NoSQL means no to SQL. That is completely a wrong notion. So NoSQL means non-relational SQL, not no to a SQL, right? So let's understand now when we need a SQL, when we need a NoSQL. So if I have a huge data set that I have to store and process the data, then I'm going to choose a NoSQL database because it can scale horizontally, right? If I have lesser number of data and I need the asset properties, in that case, I will definitely go for a SQL database. For example, system like banks and all, I can still use SQL databases. We can scale it horizontally also, but it is not that easy to scale it horizontally just compared to a NoSQL database. So it's going to be a little more tricky. So in that case, NoSQL data is much of a help. Now you must be thinking that we talked about this asset properties, right? And we might need this kind of things in a big system where we have a huge data. How do we handle that? So there is a different way to handle them. So we are going to talk about it during our event-driven architecture talks. For now, we are going to understand how we are going to handle our database in the example that we have created over here. We are now going to understand this data in a little more detail. So let's say we are talking about a NoSQL database over here. What NoSQL takes advantage of is using multiple machines like this, and we use the commodity machine in order to get things done. So let's say this is my database over here, and what this database is doing, it has multiple machines along with him to get things done. So let's say this has another few instances, so I'm not putting the IP addresses, so just assume that they are different machines in some other places, and we are going to get this stored over here. So let's say whenever a data comes over here, he sends this data to another machine over here. So let's say another data comes. So let's say this data comes now, he also gives it to another machine to store the same, right? So you must be thinking, what if this machine goes down? So what will generally happen is he will give the data to multiple servers in order to handle it. So a copy would be stored with him and the copy will be stored with another server over here. So just in case if this machine is down, so we still have the data with the other machines available as well. And now when I need to have more machines, what I'm going to do is I'm going to spin up new machine. And he is the one who knows about all these machines. So the moment the request come to him for one of the document, he might have the document or he knows who has the document. So he will go ahead and contact. So if he needs this record over here, so he knows that the document is with him. So he's going to go to him to get the document and send it back. Right? So you can understand that how we are scaling. So the moment we feel that we are having more queries, we are going to spin up a new machine who's going to handle this additional load. And whenever he gets a new document, he is going to pass on the load to the appropriate guy. So he will start taking on the load from it, right? And again, we are not going to give it to a single guy. We might give a copy to another guy, right? So we are going to understand how this is all done, right? How this is taken care, how this machine knows about it. And it might happen that if the data is pretty much sensitive, we can have multiple copies, not just 2 copies, we can have 3 copies as well. but we need to make sure we are not giving the same copy to both the guys, right? So now what will happen if these two guys fail? So let's say this and this guy fails, we still have the copies of this guy stored with somebody else, right? So here I just gave you a naive example with 2 or 3 copies of data. In the real system we might have more number of records. So how this all happens? So let's say we have a record, right? We got a record. So let's say this record came into me, right? So I have some information over here. So the name is Tom, country is India, city is Mumbai, mobile is something, and gender is male. And we are going to pass this through this hash function over here. And this hash will generally produce some output. So I'm going to get an integer from this hash operation, right? And this number is pretty big and we don't have that many number of machines. So in order to fit into these machines, we need to do a mod with the number of machines that we have. So we have 6 machines over here, right? So this mod with 6 is going to produce a number between 0 to 5. So that number is 3. So I know that I am going to give this copy to my third machine or the fourth machine. So I know this data is going to this machine over here, right? So what I'll do is I will take this data and put it into this system. So this work of distributing this data is done by this system over here, right? So now if you want to scale, we can have 2 other systems as well who can help this system in order to get things done. So this new data that we have over here is going to the third machine. So it's going to come and sit over here. So we can have several other strategies by which we generate the second number. So we can use a completely separate hash function. Let's say that hash function has produced a number which is number 4. So I can put this data over here and I can use another function, and let's say that number is produced as 0 and I put it over here. So if I add more machines, they should all be using the same hash function so that the data is always consistent and stays over here. So this is how the data is scaled, right? So we are not adding more compute power, but we are using normal commodity machines over here, and we are using commodity hardware in order to store the data and retrieve the data. So if a machine is unavailable, it does not impact to me. As a matter of fact, if 2 machine goes down, it does not impact me. As long as the number of machine that goes down is less than the number of copies that we are keeping, we are never impacted by the same. So this is how a NoSQL database works. So we can scale as much as we want. We don't need to add storage to a single machine in order to scale. So the databases that we see in this diagram over here, so all of these databases, even the cache, even your database, even your file storage is all going to use a similar strategy in order to replicate the data. As I mentioned earlier, so we have avoided successfully single point of failure. And how do? We do it with the help of duplication or replication, you can also say. So we replicate the data, that we store the data in such a way that if the failure happens, it does not fail everything, right? And now we can even make it better. Let's say these 2 machines and these 2 machines and these 2 machines, right? So let's say these 2 machines are in Europe, these 2 are in Asia, and these 2 are in US. So if a region completely goes down also, I can still serve my data. And also we are going to try and see that we can put it in a separate data center. So this machine is at DC1, this is at DC2. Again, for Asia, we have DC1 and DC2, and this is also at separate data center, right? So what will happen is they are in a completely separate data center. So if a data center goes down, that means 1 machine goes down. If a region goes down, means 2 machines goes down. But we have kept our duplication or replication factor to 3. So that means if a single region fails, I am still not impacted. I might have a little bit of latency, right? So let's say I am a U customer who is querying this data. So this data center is down. So my query will be routed to either Asia or to US. but I'll still get my data, right? So this is to make sure that even if this data center is completely destroyed by, say, flood or by tsunami or whatever, we are safeguarding our data, right? So you can have a high number of replications, to 5 or 10 depending upon the nature of your data, so that we can save your data to a great extent. And also we have recovery strategy. Let's say this data center goes down and these two machines are gone, completely gone, right? And two new machines are spinned up when the data center was up, but they don't have your data, right? So let's say your data was completely destroyed, and when you recovered back, you got two new machines, right? Now what will happen is this guy over here, he knows like what was the data held by him. So he will pass on a copy of this data that he was previously holding, and he will make sure that he is up to the mark in order to serve the data, right? So he will immediately send these files to him to make him recover when, let's say, this data center was completely destroyed or the machines were completely destroyed and the data was not recoverable, right? So you can see that how easily these guys has helped him to recover the data that he has lost, and now he will start responding to the traffic once his data is recovered back. So he is back in the business, and these guys were removed since they don't have the data now. Now there is a problem. What happens if I wanted to scale this even more? So now I have a seventh machine, right? And we did a mod with 6, and now we have the seventh machine. So all the data goes for a toss, right? So the number changes. So if I do a mod 7 with this number, what I get is a 1, and the data should be over here, right? How do I add a new machine over here? So we are going to talk about this in the next episode. How do we add more machines over here? So if we add more machines, our mod function changes and all the data changes. How do we safeguard that, right? So do think about it. It would be great to know what you think, how we can save it. And if you know the answer and if you want to learn more about it, then please come back on the next episode where we are going to discuss this in lot more details. So with that, since it's new year, I am going to end the episode over here. So do let me know your thoughts on the video. Do let me know if you have any doubts or questions on the same. Once again, Happy New Year to all of you. And thanks again for all the love and support for the channel. And hoping to have a great year with you all, with lot more videos and lot more fun down the line. So with that, Happy New Year once again, and we'll end the video over here. See you soon again. Bye bye and take care, and have a wonderful day ahead.